No lithium, no cobalt, no nickel. This battery runs on sodium, the same element as table salt, one of the most common on Earth. By the end of this video, you'll know exactly what's inside a sodium-ion cell and how it actually stores and releases energy. Let's build one. First, why sodium at all? 3 reasons. Sodium is roughly 1,000 times more abundant in the Earth's crust than lithium, so it's cheap. Sodium doesn't react with aluminium, so both sides of the cell can use cheap aluminium foil. Lithium can't do that, and because of that, a sodium cell can be safely drained all the way to 0 volts for shipping. Cheaper, safer, and made from materials found almost everywhere. Here's the cell built layer by layer. On the left, a thin aluminium foil, the negative current collector. On it, the anode, hard carbon, a disordered carbon that stores sodium. Then a thin porous separator soaked in electrolyte. It lets sodium ions through, but keeps the 2 electrodes from touching. Then the cathode, a sodium vanadium fluorophosphate, we'll call it NVPF, which holds sodium in a rigid framework. And finally, another aluminium foil. These are real thicknesses. The electrodes are about 65 microns each, the separator just 25, thinner than a human hair. Zoom in and you can see where the sodium actually lives. In the hard carbon, sodium tucks between and inside disordered carbon sheets. In the cathode, sodium sits in the open channels of the NVPF framework. Charging and discharging simply moves sodium between these 2 homes. Now watch it work. When the cell powers something, sodium ions leave the hard carbon, slip into the electrolyte, cross the separator, and insert into the cathode framework. At the same time, electrons can't go through the separator, so they travel the long way, through your device, doing the work. That's the current you use. As sodium drains from the anode and fills the cathode, the voltage slowly falls. This curve is the cell emptying in real time. Plug it in to charge, and everything runs in reverse. The charger drives sodium ions out of the cathode, back across the separator, and into the hard carbon. The cell refills. Sodium just rocks back and forth between the 2 electrodes, which is why these are called rocking chair batteries. So that's a sodium-ion cell, 2 electrodes, a separator, aluminium on both sides, and sodium shuttling between them. You now know what's inside and how it works. But here's the next question. Why does this cell rest at about 3.7 volts and not 3 or 4? The voltage is hiding in the chemistry. That's the next episode.